Hello everyone, good day. For today's video, I will be teaching you about rational functions, equations, and inequalities. But first, let us define what is rational functions. A rational function is any function which can be written as the ratio of two polynomial functions, where the polynomial in the denominator is not equal to 0. It can be written in form of f of x is equal to p of x over q of x, where p and x are polynomial functions of x, and q of x is not equal to 0. However, the function of f of x plus 4 over 0 is not a rational function because its denominator is 0.
Now, let us solve rational equations. But what are rational equations? A rational equation is an equation containing at least one rational expression. Rational expressions typically contain a variable in the denominator. For this reason, we will take care to ensure that the denominator is not 0 by making note of restrictions and checking our solutions. For example, we have a rational equation 5 over x minus 1 over 3 equals 1 over x. To solve this rational equation, first find the LCD of the equation, which is 3x. Also, take note that x is not equal to 0, and then multiply both sides by the LCD, 3x. Using distributive property, distribute 3x to the equation and we'll have this. 3x times 5 over x minus 3x times 1/3 equals to 3x times 1 over x. Simplify and solve. We have 15 minus x equals to 3. Transpose 15 to the right. We have negative x is equal to 3 minus 15 or negative 12. Therefore, we have x equals 12 by dividing both sides by negative 1. Check your answer by substituting 12 for x to see if you obtain a true statement. Let us have the original rational equation that we have earlier, then substitute 12 for all x variable. By performing the operation, we are correct that 12 is our solution for the given rational equation. Now, we will solve inequalities that involve rational expressions. The process for solving rational inequalities is nearly identical to the process for solving polynomial inequalities with a few minor differences.
Let's just jump straight into some examples. Before we get into solving this, we need to point out that this don't solve in the same way that we've solved equations that contain rational expressions. With equations, the first thing that we always did was clear out the denominators by multiplying by the least common denominator. That won't work with this, however. Since we don't know the value of x, we can't multiply both sides by anything that contains an x. Recall that if we multiply both sides of an inequality by a negative number, we will need to switch the direction of the inequality. However, since we don't know the value of x, we don't know if the denominator is positive or negative, and so we won't know if we need to switch the direction of the inequality or not. Now, the basic process here is the same as with polynomial inequalities. The first step is to get a 0 on one side and write the other side as a single rational inequality. This has already been done for us here. The next step is to factor the numerator and denominator as much as possible. The next step is to determine where both the numerator and the denominator are 0. Now, we need this number for a couple of reasons. First, just like with polynomial inequalities, these are the only numbers where the rational expression may change sign. So we'll build the number line using these points to define ranges out of which to pick test points, just like we did with polynomial inequalities. Here is the number line for this inequality. So we need regions that make the rational expression negative. That means the middle region. Also, since we've got an or equal to part in the inequality, we also need to include where the inequality is 0. So this means we include x equals negative 1. Notice that we will also need to avoid x equals 5 since that gives division by 0. The solution for this inequality is x is less than 5 but greater than or equal to -1. Thank you very much. I hope you've learned something about my video. Thank you and have a great day ahead.